as I was saying before I got so really cut off there, the not the perps, the Sarracenias are sort of basically finished growing and starting to colour up with the coldening nights, if you want to have a phrase like coldening. Yes, I know. But hopefully you're going to be impressed with what I'm going to show you here. So remember, fellas, this is this one here. If I can get it on the spot, can't I? Yeah. This one here. He's put up these massive, well, I don't know, they're massive pictures, but they're quite big. Remember, this pot is down about 2.5 inches from the top there. So basically, this plant is twice the height of that one there. And remember, it's all coming out of a ring of newspaper cellulose with a sand core. If I take the lens off there and maybe get a bit of sunlight in there, you can even see that it's fattening up. It may, if we get warm weather, chuck out another couple of pictures. I don't know, though. I think it's just, you know, fattening up for the dormant period sort of thing. But all the pictures are going to colour up. But that's quite good, considering there's no peat in there. So what we've managed to do this past season is split the peat and sand problem, you know, break it all down, and basically what you're doing wrong with the peat and sand is you've got to have really your organics down the bottom, basically your cellulose, your bark. Because as you can see, the only one that's really done anything in here is the one with the bark chip down there against the sand. So basically, I would suggest to you that maybe bark chips on the bottom in anaerobic conditions might be what you want. But I'm testing that out, as you'll probably see shortly when I get things going. None of these did much after last season, basically because the problem is the perlite. The perlite can grow the red organism, but only when it's saturated water. So whether they're jellyfying their perlite, or they've got a special, they talk about this 50-50 peat and perlite sort of thing. Maybe it's more precise than just 50-50. Maybe you've got to have like 55% peat and 45% perlite to make sure that the perlite stays fully saturated with water and therefore aerobic. So we were having quite good success initially last season with the fresh charcoal. Mainly because I was watering it quite regularly, you know, an hour, 90 minutes, 2 hours, depending on where we had 46, 47 degree days sort of thing. And while I was doing that, of course, the charcoal was wet and remained anaerobic to some extent, and therefore was functional. Whereas I think this is the big secret behind Terra Preta. The reason it doesn't work like it's supposed to is that the magic missing segment of the argument is the charcoal has to be anaerobic. It's an anaerobic situation. So all the bells and whistles that come off Terra Preta, or biochar that they're calling it now, is it only works basically when it's anaerobic. So having it on the top of the pot and not keeping it wet, damp is probably not quite good enough. It has to be wet. So while it's wet, like you're watering it every couple of hours, got a misting system or something like that, it'll be wet enough to be getting to that anaerobic sort of stage. A bit like having a rusting nail out in the open. A rusting nail will be strictly anaerobic, but a rusted nail, you know, post haste sort of thing, no, that's not strictly anaerobic. It has to be a rusting nail. So like this has to be wetted charcoal. So the only way you can really do that is to get it down the bottom of the pot. And of course we did a few experiments, and you know, when you do that, it takes about 3 weeks and you get some reaction like that. I tried it with what do you call it, paraffin candles at the top, and it's slightly different there. But again, with the polystyrene on top, you've got some greening, a slight greening in amongst the polystyrene, but look how crystal clear the charcoal was. And if you remember that man from the Pond Guru shop in Great Britain, somewhere amongst Great Britain, he talks about to keep this functional, it's got to be nice and pristine on the outside sort of thing. You can't get all those holes blocked up, because even though it's just like a combination, you've got the strict anaerobes in the centre of the charcoal basically, and then you've got these other organisms, and the organisms on the outside can occlude, and it stops its functionality to some extent. As you can probably see here, the fly traps are sort of going into a sort of semi-dormant state. This is the big question: can you actually keep them growing during the wet, or our so-called winter period? Because that was the key point that came out of the Robertson Hustings paper. In the wild, where it doesn't snow, where there's no snow, the actual plants don't actually go into a dormancy. They keep slowly growing through their so-called winter period. That's if you read the paper properly. They said the only time that the Venus flytrap goes dormant in the wild is due to dehydration of the soil surface. It doesn't actually go dormant due to their winter conditioning, because they don't get snow. It doesn't go below 0 degrees, basically. They occasionally get snow, but it's very rare, you see. So that's the key point. And then basically, they continue to grow. So they're a bit like a cape in a way, I assume. But as now we're going into this sort of, we're now switching over from the fly traps into these capes, because as my friend Peter Koslag pointed out, it's a mountainous species, and of course it doesn't actually go, as long as you don't go below 0 degrees, which we don't do really in southern Adelaide. If you go down to Albany, it sort of impinges on there, sort of thing. And they're telling us we're going to have the coldest winter on record. I don't know how they know this, considering it's going to be 27 next week. It's almost unheard of to get these sort of temperatures as we're getting into May, sort of thing. I mean, by the third week of May, I should be out there looking at top prey foliage, and that's basically only 3 to 4 weeks away. And yet, when I get out there, what am I going to see this season? I mean, if we are going to have the coldest winter, it's going to be a very short, very precise coldest winter on record. I don't know. It's going to be very bizarre. So it's going to stay warm, suddenly get really, really cold, and we get the coldest on record. I don't know. Anyway, I've got a root of a cake that's actually starting to. Hopefully, I'm still on spot colour there. It's starting to put, and the tentacles are quite colourful in this one. When you wet it up, you can actually see the difference between the polystyrene down there, the isolite, and the sand on top. And the sand is slowly changing its colour. And I bought another 4 bags of sand, and they're crap. They've either changed the formula, made a mistake with the formula. Some chaps say, "Oh, I've run out of this." It will still be the same. It's only slightly different. It's slightly different enough to be annoying, put it that way. So these ones with the bark chip now are coming. It's starting to look quite good. So that's why I'm doing some tests with bark chips on the bottom, sort of thing. I'm going to do a bucket. I've just set up some bottles, as you'll see shortly, and as we go, just checking it's still running. Nothing worse than having talked for half an hour and finding you haven't pressed the record button. With you, Richard, never. Anyway, I've got some cuttings in here, and they are starting to get a bit of vigour, even though the top half of the pot is just the sand, basically, with occasional bit of this cellulose that somehow got in there by stray, I think. So you got chalk on the bottom. It took a long time to get going, but as I said, I think the combination is going to be chalk on polystyrene. But as you can see from the bottle work in a minute, I don't think you have to mix it. And I'm coming to other conclusions, which I'll show you shortly. How I'm going to set some stuff up in the garden as well. Once I'm pretty certain of whether I need to put bark chips on the bottom or something organic on the bottom. So on and so forth, because this one over here seems like the newspaper cellulose on the bottom has sort of run out, and I'm introducing the idea or concept of nemacast. So you've got vermicast, which is from worms in calcium-rich soils. They form this sort of 50-50 between the minerals and the organics that go through their digestive system, what they eat as they go through the soil, basically initially worked out by Charles Darwin initially, but which is quite good. And so we might as well adjourn down to these things. I've got something really interesting I want to show you. This is just, I think it's going to put the cat amongst the pigeons. So I've been doing a lot of bottle work, as you can probably see. I said I'm going to do some work with trying to go back to bran again, put it into anaerobic conditions with sand on the top. So basically you put your bran in the bottom of your bucket, and just cap it with down the top so it becomes anaerobic. Because I came across this thing online that's basically said that nematodes are more predominant in sandy soils, and I've been in my Cannabis Plant Society. I was in there for like 30 to 35 years, and nowhere do they, anywhere along the time, like every 5 years or so, did we have a lecture or something where they impressed upon the fact that, well, we're, a sandy continent, coastal sandy continent, a lot of, we call it Sand Island if you want, therefore it's important to discuss nematodes, because nematodes are more predominant in sandy soils as opposed to silt and clay and loam and all the other stuff. That's their preferred soil is sandy soils. Of course, there's good and bad nematodes, of course. I remember Terry Petozzi once saying that Venus flytraps they looked at in the laboratory were heavily infested with nematodes. So I don't know whether they're good or bad nematodes, but it was very interesting to hear that. But you would have thought that would have sparked a discussion, okay, well, I'll go and research this, or I'll find someone, we'll invite an expert in about nematodes, blah, blah, blah. No. And I'm wondering whether that's because, again, it's this thing, because once you do some research, you get like nematodes, protista underneath, and then on the bottom you've got bacteria, of course. So if anyone would have looked at that, you think, okay, it's bacteria. What's the difference between bacteria and fungi? Well, fungi are predominantly strictly aerobic organisms, so they have to have a bit of oxygen there to some extent. So I can't remember if they're strictly aerobes, or they do have to have some sort of oxygen there to actually, to grow to some extent. So whereas bacteria can, either be, the usual three things they say, they're strict anaerobes, facultative, which means they can grow there, but they, would prefer it the other way around. Facultative can go both ways, of course. And then you've got the strict aerobes and things like that, and there's a couple of others too, but because these terms of course come through Koch and Pasteur and things like that, people who weren't really, they weren't in the English language, so the words we've got in the English language might not be exactly what they were trying to get across or represent, and vice versa the other way around as well. Anyway, so I've done a lot of work, but this is the interesting thing I've set up this one with charcoal and just charcoal and the egg sort of thing there. And what was interesting is the charcoal, as I was shaking, it went up to the top and it stayed there. But the red goodness has been able to descend down the container, whereas the one I tried it with a candle and it's got stuck. And also it seems to be, as you can see there, I don't know if you can see that there, but, it's working, but I think the candle idea is inhibitory. So this idea of putting a candle in there, I think I'm going to hold that back until we get some more information. The other important thing is to notice the odd bit of eggshell that gets in there really does seem to grow the organism quite well. I can get that off and get in. It's quite low light now under this tree now. We're going in. The odd bit of eggshell's got in there by accident, because that's supposed to be calcium carbonate, of course. You might want to try a bit of dolomite, limestone, calcium, magnesium carbonate down the bottom or down there. But I've done other ones where I've actually, and these results are coming back in 9 days, so you basically get initial pinking in 9 days, and then about 9 days later it really fills up and sort of things like that. I've set up some with some bark chips down the bottom, the phenolic-y smelling ones, bark chips, pine bark chips, with some no candle. And I've also done one with just bark chips down the bottom, no charcoal. So, we'll see how that goes. And you might get a surprise. We might find that we can just use pine bark chips and no charcoal. But, so I don't know if the bark chips is going to improve the charcoal. Do they act a bit like a candle, being phenolic-y and candle being waxy? You can see the, rough connection there. So anyway, so that's basically what I'm doing. I'm getting more data back now from the charcoal side of things and putting the other thing. Yes, I'll just put this down for you. Quick. Yeah. Yeah, so I didn't quite have one prepared earlier, but as you can see, I've got some more bag of beans. I actually got three for another one for doing experiments and potting up into buckets. But these are ones I'm thinking of putting these into the garden, and I'm thinking the idea is, why don't I just put them straight into the garden and maybe like have a layer of bark chips on the ground, drop that into the hole, stab this with a soldering iron so it doesn't split the bag, it just melts holes in it, top and bottom, because these bottles are filled up with water, so they're, I would say, more anaerobic to strictly anaerobic sort of thing. But this will happen over time because it's giving off reductive, the polystyrene gives off reductive flammable gas, of course, due to the easy water sort of thing that you can look up online. So you might want to look up these clips by Pond Guru and just type into easy water, EZ water, and that'll take you down the pathway, which will, tell you about all these plastics that do this sort of stuff. Polystyrene might not be the best plastic that does that. You might find other ones that do it. But we've found that the organism can grow in the sponges, which is urethane foam, and of course we did a lot of work with urea formaldehyde foam, the floral foam stuff, and we got reasonably good results. But what happens if we go back with that later on and mix that with the polystyrene and maybe charcoal and things like that? So we're probably going to get to more exotic media, but we're basically really trying to get away from the peat and maybe have a connection with the charcoal or the biochar or terra preta. But I think the important point is the organics should be down below in a anaerobic to strictly anaerobic environment sort of thing, and that's where all the work is done basically, and all that goodness then comes up by the wicking effect, I suppose. And of course roots going down, but because everyone says that CPs have mega roots and they're non-mycorrhizal sort of thing. So the other thing is what's going on with the sand. Sand almost seems to be somewhat inhibitory to a certain extent. So putting sand on the top might not be the best idea, but it's the only one we've got at the moment. It's just we've got to this idea we do have to separate the peat and sand. All this 50-50 peat and sand really. Of course, now they've gone to 50-50 perlite and peat sort of thing. And the perlite does grow the organism, it does grow it quite well, but only when it's wet, of course, you see. When it's saturated, when it's anaerobic. And of course, and then the other thing is, how do we keep it red and how do we keep it green? When you try it with sphagnum, it goes green, and as I said, it's descended quite well down the, as you can see if we can get it in the sun, it's got all the way, almost, it's slowly descending, halfway out there, but it's getting down there. So, but it's still that verdant green, that sort of, not quite malachite green, but it is quite verdant. Whereas in the cotton wool, it's quite red. So, with a little tiny streak of almost a sagey glaucous sort of, there, if you can see that there. I don't know if the camera can pick that up. If I'm still on spot colour, might get an interesting shot there. But talking about those odd things, one here, I can get this into the sun. It's these oddities that I like, where you got this Gelbstoff, what they call Gelbstoff on the top, and down here, in amongst the red, you got this sort of little green little ones, and the occasional one around here. But these ones were the original ones that showed up down there. So why are they green below the Gelbstoff? And then you've got the occasional spots here. What is it, the occasional spots there? So, interesting. And by the way, these layers apparently is known as the limnion. And you've got the epilimnion, and then you've got the hypolimnion. That, of course, if you had more than the layers, I suppose you would... But you basically have two layers, basically, I get the impression. You can have one layer and then you can have two layers. So you've got the epilimnion is that one there, and then the hypo, the one the below, is the hypolimnion. You might want to look those up, but that wasn't my area of expertise in biology. I don't think I had an area of expertise. I'm making my area of expertise now. And said I think I'm going to be changing this idea on terra preta and biochar I think I've cracked the salient, important piece of information they either don't know or they're not telling you. Your biochar has to be down under the ground, so it's anaerobic, or becomes anaerobic.